All right, tested the sound, it's supposed to work, so let's just jump right in. So here's the first problem. You should there should be a B right here. Oh, I mean a C. Okay. You should recognize this because we did this exact same problem. The only difference is it had B's instead of C's. The exact same problem. It's in your book. But regardless, let's go through what do we got, right? That should be C. I don't know why it's not a C. But anyway, so the first step one. Step one is well, you could kind of straight off step one and step two, but I'm going to say step one is common denominator. So in this, because we have this expression right here, sort of sub-step, we need to factor or AC method, or reverse box, or difference of squares. Okay, I'm spelling this wrong. Oof. Difference of squares. So this is all step one. So in this case, I mean, I could factor it or I could reverse box method, but the bottom line is the difference of squares works the easiest. C squared, that's a square. 9 is a perfect square. So the difference of squares tells us that this factors to C plus 3 and C minus 3, which is exactly what I have. So that lets me know that this is my common denominator. Now, what I saw a lot of times is this is where folks got stuck. Okay, I got my common denominator. What do I do next? Well, next, you need to check exclusions. The reason being is because your answer that you actually get might not work. And so you want to have those exclusions already listed. So I look, I've got this expression, and both of those are right here. So I just need to test these two. And when I say test, I mean you take the expression, set it equal to 0, and then solve it. So I subtract 3 from both sides and get C equals -3. So that's my first exclusion. C minus 3 equals 0. I add 3 to both sides. C equals +3. So those are my exclusions. What does that mean? That means after I finally get my answer cannot be 3 or -3. Okay? Just real quick, what does an exclusion mean? It means it is the value that I plug in for my variable that gives me 0. If I plug in -3 for C, that's -3 plus 3. -3 plus 3 is 0. Can't have it. Right here, if I plug in +3, 3 minus 3 is 0. Can't have it. Even if I plug in +3 here, +3 to the second power is +9. 9 minus 9 is 0. Can't have it. So those are my exclusions. So I need to find a common denominator, then I need to find my exclusions. After I do that, I go back to my common denominator and I change my fractions top and bottom. Now I say top and bottom trying to help you remember, because what am I doing? I'm taking the first fraction and I'm multiplying it top and bottom to give me my common denominator. This is C plus 3. So I need to multiply by C. Oops. I need to multiply by C minus 3, right? Because that's my common denominator. C plus 3 times C minus 3. So I need to do that top and bottom. Because as long as I'm taking my fraction and making the same, I'm doing the same operation top and bottom, it doesn't change the overall value of my fraction. It may make the numbers bigger, it may make the numbers smaller, but it doesn't change the overall value. It's like I've been saying for a while. It's like taking a paper dollar and getting change. I got 4 quarters. It is still worth $1, but the visual value, not value, but the visual thing has changed. It went from being paper to 4 coins. Okay, so I do the same with 5. 5 over c minus 3. So I'm going to multiply by c plus 3. And I need to do that top and bottom. And I think once somebody asked me this earlier, c plus 3 times c minus 3 and c minus 3 plus, times c plus 3. Switching the order in the denominator doesn't matter. It is the same as saying 2 times 3 or 3 times 2. Those things give me the same answer, so I don't need to worry about it. And then here, I've got 10c minus 2 over, and I'm not going to write the squared part. I'm just going to write this because that's what our c squared minus 9 factors to. That's my common denominator. So if I'm doing it in this format, common denominator, boom. I check my exclusions, boom. Next, I change my fractions top and bottom. Notice the last fraction doesn't need to change because it already has the common denominator. So changes fraction, boom. So 4, I'm going to distribute. Well, you know what? No, let's do this right. I'm going to ignore the denominator. We're going to ignore the denominator and then distribute. So that's my fourth step, is ignore the denominator and distribute. Now, the thing is, I'll just say this real quick and then I won't go into it. I don't like really doing that. I actually like multiplying everything and canceling off my denominators and just being left with the top. But that seemed to be more difficult, so we're just going to keep the denominator and we're just going to ignore it. So now I'm going to look at the top. I have 7 times c minus 3 plus 5 times c plus 3 equals 10c minus 2. So now, like I said, next I'm going to distribute. Distribute just means I multiply my number on the outside times all the numbers on the inside. So that's 7 times c and 7 times a negative 3 plus 5 times c plus 5 times 3 equals 10c minus 2. Next, I add like terms. All right, so I add like terms. I got 7c and 5c, that's 12c. I've got negative 21 and positive 15. So that's going to be negative 6. So now I've got an equation that has letters on both sides and numbers on both sides. So now I'm going to move the numbers to one side and move the letters to the other. I move something to the other side by doing the inverse operation. So I do it on both sides. So in this case, I'm going to start with the 6. I'm going to add 6 to both sides. That is the inverse. Minus 6 or negative 6 and adding 6 or positive 6. That is the inverse. That is the opposite operation. As long as I'm doing the opposite operation to both sides of my equation, it's just like with the fraction. It doesn't change the overall equation. It may move some stuff around, but it doesn't change the overall equation. So the 12c just comes down. It doesn't change. Minus 6 and plus 6 is 0, so it goes away. And then I've got 10c. I've got a minus or negative 2 and a plus or add positive 6. So that's going to be plus 4. I want to move the letters to the other side, so I'm going to subtract 10c from both sides. It's brought to my attention, if you take 12c and subtract 10c, why don't the c's go away? It's the same. It's like saying I got 12 apples minus 10 apples. I'm still dealing with apples. So the word apples don't go away. So in this case, 12c minus 10c is 2c. So now I got 2c equals 4. That is 2 times c. So I do the inverse operation on both sides, which is division, to get rid of it. Because ultimately, I want to isolate my variable. I want my letter to be all by itself. And dividing by 2 on both sides gets rid of this 2. So I have c equals 2. So that is my final answer. Now I go back. Go back to the exclusions. and check. Okay, I go back to the exclusions and check. C can equal +3 or -3. C equals 2. That's not one of them, so that's my answer. Boom, I'm done. Now let's jump into number 2. And I'll do this by page, so we'll finish. We'll stop the video after this one. So this. Now, first thing, oh no, somebody might look at this problem and say, we never did a problem like that. We did a problem that looked like this, and then we did a problem that looked like this. So we may technically have not done a problem that looked like that, but we've done a problem where you had to do both of those steps. And you should be able to put those two together and see what you need to do. So first, I'm going to totally jump and just give you a standard problem like this. This is a linear equation, and we've done problems like this, and if you're taking this test, you should know how to do this. This is a linear equation. It is also called a two-step equation because you do 2 steps and then you're done. What do I need to do first? First, I take care of the addition or subtraction. So I'm going to add 1 to both sides. That gives me 2x, that cancels off, equals 6. Then I do the opposite of multiplication, division. So I divide by 2, and I get x equals 3. Now, I did this problem because this problem is like in a direct has a direct relationship to this. It is the same principles that we did here work here. The same principles that we did here work here. So I'm going to give you a second to absorb that. Then I'm going to erase all this, and then we're going to do that problem. But I'm going to say it again. The same principles that we did for this two-step equation work right here. And that was your second. Come on, we got stuff to do. Hurry up. Excuse me. So let's do this problem now. Let's do it for real. Plus 4. It's important that you realize that this is not under the radical. So I made this radical really long. I had to back it up some more. Okay. Somebody asked me today if this 2 is being multiplied by that. Yes. If you've got some variable that's next to a letter, that just is the epitome of multiplication. 2 times x, 2x. Well, even though the variable is under this radical, the same rule applies. If I have a number next to a radical, remember what I was telling you about radicals, that something on the outside of the radical and something on the inside of the radical, they can't interact. So it's just the same as saying 2 times x. 2 and x are 2 different types of terms. So when I'm multiplying them, there's no simplification. If I said 2 times 4, they're the same kind of number. They're the same kind of term. So I can say 2 times 4 and get 8 because they're the same kind. They can interact. But 2 and x, they don't really interact, so I'm just left with 2x. So when I have a square root and a number on the outside, they can't interact. So I'm just going to have 2 times that, and that's that. All right. So now let's continue. So this technically is just a 2-step equation. So the first step is I need to get rid of what's being added or subtracted. So do opposite or inverse of add or subtract. So in this case, I'm subtracting 1, right? -1, subtract 1. So I do the opposite or the inverse operation of subtraction, which is addition. So I add 1 to both sides. So I'm doing this because I want to isolate this x, this big bad x right there. And I have to start by getting rid of the numbers that are on the outside. So that's why I'm adding 1 to both sides. Now I have 2 times x plus 4 equals, that's 0, so that goes away, 6. Now I need to get rid of this number that's in front because I'm trying to get to that big bad x. So I'm going to divide by 2 on both sides. See, the 2's cancel each other out. 2 times something divided by 2. The 2's cancel each other out. So now I'm left with just x plus 4 under the square root. But then on this side, I've got 6 divided by 2. That's 3. So now I do the opposite or inverse of multiplication or division. Yeah, I wrote divide and I said division. You'll be all right. So anyway, step 1, step 2. So now I'm right here. I've got on the left side a square root. On the right side, I have a number. I need to get to this x. So in order to get to this x, I need to get rid of the square root. The square root, I do the opposite of the square root now. So do the opposite or inverse of square root, which is what? There's a hint, is I take the square of both sides. If I take the square of the left side, all it does is get rid of the square root. But in order for my equation to still be balanced and unaffected, I have to square both sides. So over here, I just get x plus 4. I am one step closer to isolating the variable, getting to that big bad x. But on this side, I got 3 squared, that's 9. So now I'm just going to solve the linear equation that's left. And just in case you were wondering, when I say linear, okay, what it refers to is that the highest exponent in my equation is 1. So that's when you know you have a linear equation. The exponent for x is 1, it's a linear equation, boom. Okay. There's more explanation, but we don't need to do all that. So anyway, now we solve the linear equation, which is go back and do these other steps. I've got x plus 4. I want x by itself, so I'm going to subtract 4 on both sides. X equals 5. Now, I tried to tell folks that even though you got an answer, you need to go back to the original problem and plug that answer in to make sure the check works. So 2 times the square root of x plus 4 minus 1 equals 5. I need to plug 5 in here. So 2 times the square root of 5 plus 4 minus 1 equals 5. The square root of 5 plus 4 is the square root of 9. The square root of 9 is 3. So that's 2 times 3 minus 1 equals 5. Does 2 times 3 minus 1 equal 5? Well, 2 times 3 is 6. 6 minus 1 is 5. Yes. So my check works. That's my answer. And that's the first two problems.